Now, under normal circumstances, when you boot your system, a grub menu is presented, and it boots without fail. So in this case, grub version 2, or close to 2, launches, presents us with two options, which include the standard boot option, which is illuminated in white, and a recovery mode, which launches single user mode in the event that you encounter problems booting your system under normal multi-user mode run level 2. So that's normal circumstances. Let's go ahead and boot anyway, just to see how things come up without making any changes. So this loads drivers. And momentarily we get a desktop. We're able to log in, authenticate, and use the system. That's all well and good. But what happens when things go awry, let's say, by human error, which is typically the case, or otherwise, such as mistakes in the configuration of the boot environment, such as surrounding the Grand Unified Bootloader, or perhaps initRD, the initial RAM disk, or the kernel itself. In those cases, a couple of options are available to help you recover the system as quickly and efficiently as possible. And they include booting to rescue mode, which is one of the options presented, as well as booting perhaps from installation sources either across the network using Pixie, or perhaps just from the hard drive as the second option on the boot menu. So what are some of those things that could possibly go awry? Well, first let's just modify our resolution a bit so that it's a bit more palpable, so that we can fit more things on the screen. This is the standard GNOME interface, by the way, and once in this particular area we can go to monitors and change the resolution to something that fits our configuration, such as 1280 by 720 or 720p. When we click apply, this will be changed on the fly, giving us the option to hold or reset the configuration. So now we're at 720p. Let's keep the configuration. This does not, by the way, change the login screen resolution, which will remain at the standard 800 by 600, but which can be changed through alternate means. So now we have a larger resolution footprint. So as we've mentioned, what happens when we have to troubleshoot booting the system? Perhaps we should get some notes going to discuss. Now, the terminal shell is available through Applications, Accessories, Terminal. You can shortcut this to the desktop by adding this as a launcher to the desktop or to the panel, either or. Place it on the panel, the footprint's smaller, and it's quickly available. And you can interact with the properties of the application to make changes to the scheme, the size, so on. So let's launch an instance of gedit. This is LCBT Deb1, so our notes are not here, but we can concatenate them later on, or we can pull the notes across and then copy them across the other way. So let's open a new shell, and we'll make a directory, LCBT Deb6x edition. And then let's SFTP over to the remote system located at the following IP address. This is the first time connecting, so we'll have to accept the public key, as usual. And once authenticated on the remote side, we can enumerate the contents of the user's directory and search for documentation. So there are a number of directories available, including versions for security, Deb6, Deb5, so on. So let's go into Deb6x. There should be a docs subdirectory. And our current local directory does not have a docs directory, but we can make one locally. And let's change into it. Then we'll get a text file. And let's take a look. And we'll just specify the name explicitly. And now we've got the file. So here's our copy of it. So let's take a look at docs and then open it. And we could have launched gedit from the shell, specifying the file name, or just file open. Either or, it doesn't matter. So gedit, LCBT Deb6 edition docs, the name of the file, will pull the file up. And then we'll append to the list new information. So system recovery via rescue mode. So a number of things can go wrong to prevent your system from booting. So features largely recoverability in the event of a non-bootable system, and also the ability to repair hard disk / file system errors in the event that they occur. With modern file systems like ext3 and 4, errors are few and far between, but nonetheless, every now and again, especially as your disks approach or start to show signs of aging, it becomes more and more of an issue, of a concern. So, with that said, let's define some tasks surrounding how we can corrupt our system to prevent it from booting. So the boot environment largely surrounds the / boot directory. So boot environment focuses on / boot and the contents within, and the wider resolution makes this a bit more tractable. And with that said, let's SU in and take a look at that structure. Navigate to boot, and in this directory we see references to an initial RAM disk and kernel for 2632 for this particular host. This is the virtualized host with a small footprint of just about 10 gigabytes, of which we're using just about 3, so roughly a third. So these are the boot files for the kernel and its init.rd, and this is the config file that was used to generate this kernel, and this is the system map file for the kernel. The grub subdirectory contains grub version 1.98 or grub version 2, which has its references to start the system. But again, any number of things can go wrong. For example, supposing you or another administrator renames one of these files. So one simple task could be to rename either of the init.rd or VM-linux or both, and see how the system behaves when we attempt to boot. So, one task. And let's just note this. And that is to rename kernel file. The kernel file for Linux is always located in boot and is named with the prefix of VM-linux-version. For the past number of years, that version is largely 2.6 followed by a minor release. So it's largely VM-linux 2.6 and subsequent minor version information is what you'll find. For older releases of Debian and other distributions, the kernel version is 2.4 and the minor release associated with it. So a simple renaming of this file will make it difficult to boot the system, but it is recoverable. And since we have privileges logged in as user root, who is the owner of the file, we can move the file VM-linux to 632.5.686 to, let's say, something else. 686.old. Supposing we were performing a manual upgrade of the kernel and we backed the file up to old but neglected to provision a new kernel or a replacement kernel. So now the old kernel file is there. Now the initial RAM disk file is there, the kernel file is there, but it's now called old. How does this impact the boot environment? Well, if we try to reboot, you'll see what happens. So this is a simple change. Just alter the kernel. Now let's save our documentation and reboot the system. A number of ways in which you can reboot. You can just simply execute reboot from a root shell, or you can navigate to System, Shutdown, and select Restart System. Either or will do. This will quickly close things out, shift resolution, and kick us back to the boot environment. Now Grub will proceed with presenting us with a startup environment, which means it will think that it's able to boot the system, but then fail when we attempt to boot the system. So let's try this out. Shifted resolution. And now we're back to Grub. So here are our options. So far so good. The master boot record provided a pointer to Grub. Grub has loaded with a menu which shows two options, but Grub and the actual kernel location are two different items. So they are mutually exclusive in that regard. And if we edit either of these options by selecting the E option, which is a carryover from the former legacy version of Grub, you'll see the directives or parameters that are passed in to boot each of these options, with some new options that pertain to Grub version 2, such as the installation of the modules being explicitly referenced, for example, and the way the root file system is specified, the root partition is specified. But beyond that, also notice the UUID references to where the root file systems are located, which is a good thing in the event that some sort of technology like LVM or other storage facility relabels your root file system, the system still able to boot. But the key thing here is to note that when the system attempts to boot, it will try to boot from the boot directory, VM-Linux 2632.5686, not 5686.old. It will mount the appropriate root file system because of the UUID, which is unique to that LVM, or in this case to that particular mount point, Deb6x1. On the other system, it's LVM managed. But it will fail in finding the kernel. Now, to discard changes and return to the menu, we'll press escape. We can also edit the second one. And this second one also references the same version of the kernel, VM-Linux, but notice at the end it launches in single user mode. That's the difference, which allows you to make changes to the system sans connectivity. Now, let's try to boot as we'd normally boot by just pressing enter on the selected item. So immediately an error is returned. Cannot find the kernel. Of course, if we were to append .old, the kernel would boot. Let's edit. And if you'd like to make a change to any of these items, just navigate to the item and reference the kernel accordingly, since we've relabeled it old. Now, to boot with this particular menu item, we can press Ctrl-X. If we press escape at this stage and then re-edit, notice that the change has been lost. So the .old suffix is gone. So we'll reinstate it and then Ctrl-X to try to boot. Now, supposing we wanted to boot to single user mode to reduce the amount of time required to boot the system, we just append to the end of this line single, or we could have made the change to the single entry. Either or would work. So Ctrl-X to boot. Now notice it's booting, despite the change in the file name. Now at this stage, if we press Ctrl-D, the system will continue to run level 2, which is the graphical boot environment. If we specify the password, however, we'll be propelled into single user mode. So this is the unknown run level of single user mode with no network connectivity. Netstat.ntl, currently nothing's there. No one's available to connect to us. Notice that's the loopback adapter. That's up, not ETH0. So now we're up, and this kernel that has been launched is the one marked old. Let's take a look at the boot subdirectory, and notice that the file name is still .old. It hasn't changed. So this is one opportunity for us to change the kernel file name back to its original file name. So supposing it was this simple, that you knew that the file name was misappropriately named to something such as .old, you've changed it, booted with it, and then you've renamed it, that would fix the system. So you move VM-Linux, for example, back to VM-Linux sans the suffix, and then the grub entry now is aligned. So let's init 6 to reboot to see how this all works. Here's our menu again, and if we simply boot the option by pressing enter, this will propel us into run level 2. But supposing we wanted to cut things short, we can edit it with the E option and just append to the end of this line. There are shortcuts. It's an Emacs style editor, single, and then Ctrl-X to boot. And this will propel us into single user mode, so long as we indicate the password. Otherwise, it navigates into multi-user mode. So now we're up, we're back in business, and indeed all of our file systems are available. We're just not available for other users to connect to the system. So that's one simple way to fix matters. Just rename the file, you're back in business. The same applies for the other files, such as initial RAM disk. If you change the initial RAM disk, then it'll behave similarly. Let's move initRD to, let's say, .old, reboot, and see what happens when the system attempts to boot. So again, here's the menu, and now we no longer need to specify single because the boot will fail. So let's try to boot by pressing enter. And notice it's a kernel panic. So we've restarted. To fix this matter, a number of things are in play. We can fix the initRD by specifying its name correctly, or we can try recovery mode, which will eventually hang because of the initRD, or we can boot from the network and fix the file. So we know that the file has a name of initRD.old or version.old. So let's just go ahead and edit the file, or the entry that is for grub, tacking on to the initRD line the .old suffix. And that'll fix matters. And let's just also indicate single. And this time, let's execute Control-D to boot into multi-user mode. And here we are, back in Super VGA mode. So it's back up, and if we log in, we'll be able to rectify matters, or perhaps wreak additional havoc. And of course, that flips the resolution. And let's get a shell going. And as a non-privileged user, we see that the file has a suffix of .old. So we'll SU in and fix this problem. So now it's back intact. A reboot will work. But again, moving around file names surrounding initRD, VM Linux, and so on are among some of the problems that can go wrong to prevent your system from booting. There are also issues that can impact the grub bootloader, for example, that will prevent it from finding the different items that are available for booting your system. Notice this version of grub includes a lot more information, a lot more files than the prior version of grub. But again, the menu file in grub could be damaged to point to the wrong file, for example, which could cause your system to fail to boot as well. For example, in this version of grub, instead of menu.list, the file is called grub.cfg. So this file contains the directives that are of interest to us with respect to how the system boots. So the new version, perhaps we should just note that briefly. Let's history grep gedit, and we'll gedit our notes file, and it's referencing it from the wrong directory, so it didn't pull it up. And that's more like it. So rename the kernel file, rename init rd file, which is located also in the same directory, 2.6, minor version, and fixed it accordingly. Another task is to corrupt the /boot grub.cfg file. And this is the grub v2 config file instead of menu.list, which you'll find for legacy grub. So let's see what sort of havoc we can wreak here. Use the nano editor, and let's just expand our resolution, take full advantage of the vertical space, grub cfg. And there are some functions defined, but as we scroll towards the bottom, we'll see the entries that are booted and how they're referenced. So let's take a look at these two entries. These are the default entries that are presented to us. The first entry looks for the kernel in /boot on a UUID of the following: which can always be confirmed, by the way. So if you take this entry, since we're here, might as well, looking at it now, might as well do it now. So, and let's sun. We'll block ID Deb6x1 and then paste what we have in memory. Notice that SDA1 has a UUID that begins with 8.6 and terminates with 8.2. Ditto for the code we just pasted. So the block ID for our root file system is indeed that block ID. df-h shows that the root file system is bound to Deb6x1, which wears a block ID or a UUID of the following, which is referenced by grub. So that is indeed the appropriate label. Notice also that the same UUID is referenced for the recovery mode. So another thing that could go wrong is the corruption of this grub.cfg, the modern day menu.list. So supposing we reference a VM lineage that terminates with, let's say, .old or .new, supposing we were doing a kernel upgrade and we thought we had both files, let's say initRD as well as VM lineage described appropriately in the file system with .new suffixes. This would cause a failure as well. The second entry would work, but let's corrupt the second entry as well by tacking on .new. So this will break things. So corrupt the grub CFG file by renaming the entries. And other entries can be corrupted, such as a slight change in the UUID. That's another thing that just came to mind that might be of interest. So supposing, for example, we changed the UUID from a prefix of 8.6 to 7.6. Well, that would also corrupt matters because the root file system is being referenced specifically via a unique UUID. And if that UUID is not found, then the kernel will not be able to boot, which will cause you to have to attempt to fix it using some other means. So let's save our notes file, close this out altogether. That was the first document that didn't need to be saved. And let's shut down the other way, which is via the GUI. So we'll system shut down, and then we'll restart the system. Options include suspend, for example. Now once this restarts, grub will come up rather quickly once the services have been terminated. And now here's the menu. So let's try to boot this entry. And immediately the file was not located, both initRD as well as the kernel. How about the recovery mode? It starts, however, the initRD is corrupted, so this will also throw an error and freeze at some point. So either way, you can throw things off via grub or via the file system, causing you to have to find alternate means. Now supposing you corrupted grub altogether and the menu didn't come up, supposing you corrupted the master boot record, then the recovery mode from the DVD or from a PXE-based source such as the internet or an internal mirror could help you to reinstate your grub environment. So that's another way out of matters. Either the first DVD, boot with that, or boot using PXE and then reinstate grub. There's an option to actually replace grub on the file system after you've mounted it. So with this matter, let's run the recovery mode, the rescue mode that's made available via our PXE boot. Since we still have PXE set up, we'll just have to ensure that we interrupt the boot process instructing it to use PXE as opposed to booting from the hard drive. So let's issue a restart. And now we have a menu which allows us, we press escape to provide us or prompt us to boot from a particular source as opposed to defaulting to the hard drive. So we'll go with network boot with which is the PXE boot. And now this brings up the PXE base booter. And this will work because it hasn't been corrupted. So let's navigate to advanced options because we actually don't want to install the operating system. The rescue mode is the mode that we're interested in. Now, just like installation, it prompts us to select language, territory, the key map to use, also the mirror to retrieve the Debian files from. Let's give it, this is all temporary by the way, but we'll be consistent and just use what we've used all along. So now we need a mirror. We'll go with mirrors.kernel.org, and this will download files that have not been corrupted, allowing you to boot your system. So in a production environment, you can always find a way to boot your system, so long as you know how. For example, you could have a Pixie set up as we do, and then select one of the internet mirrors for which you should not be able to corrupt. This downloads uncorrupted files from the remote mirror on the internet. This is pulling across the net right now using wget, and will prevent us with enough of an environment to search for Linux file systems, mount them, and allow us to correct the problem, subsequently being able to boot the system. So it'll be a little bit slow or fast depending on your connectivity to the net. And if you have an internal mirror, there is an option on the mirror list to indicate that mirror as opposed to relying upon an internet-based mirror, which of course would be quicker, presuming it's on your LAN. So again, this environment will allow us, it'll search for and allow us to mount file systems. Now we know our root file system is located at Deb6x. It's important when you set up systems to note where the root file system and optionally boot and other important file systems are located, but in particular the root file system, which normally contains boot with its various files. So let's go ahead with the time zone information. Now, here are the partitions that are available. This is why it's important to have a clear sense as to which file system is root. The good news is on this simplistic setup, SDA2 is actually an extended file system which cannot be mounted. SDA5 is a swap partition which also cannot be mounted as a root file system. So if you try to mount them, it'll throw an error. However, Deb6x will mount. You also have the option to set up RAID from bits and pieces of RAID arrays, and also to not use a root file system, which will give you a shell and the tools so that you can manually mount your file systems if you know where things are. So you can create a directory like temp off of the root and then mount, let's say, Deb6x in temp, for example, and then change root if necessary. So let's mount Deb6x. Now here are some options. We can reinstall grub. So for example, if you note that the problem is that you're unable to boot into grub from the BIOS handoff, then this is an opportunity to reinstall the Grand Unified Bootloader on that hard drive. You can also select a different or reboot. You can also execute a shell in Deb6x or in the installer environment. If you're in the installer environment, so long as you know the partitions that contain root, boot, etc., you can mount them manually. But if you'd like to execute a shell in Deb6x, which will change root it for us, then go ahead and do so. Now we have a shell. It doesn't look like much, but here at the bottom left, we actually have a shell. If we df-h, you'll see that Deb6x is mounted to root. And if we change into boot in ls, you'll see the files. Now, the files don't have a suffix of .new, but if we change into grub, for example, and modify grub.cfg, we'll see where the damage. And in fact, if we just Control-W search for .new, we'll see that this is the first entry. Of course, you wouldn't necessarily find these errors so quickly on a production system. You'd have to comb through each of the options to correlate the differences accordingly to find that the discrepancy exists. Now we have saved the changes, and we can actually reboot. The system will reboot. So we actually have used the recovery mode effectively. So let's go ahead and reboot, or if we type exit, we have the option here to reboot the system. Again, there are other shells, such as the installer environment, or the option to mount without, for example, let's go back. We can go to a shell without a root file system. mounted. This is like the installer environment. And in this particular setup, we could make a directory calling it temp, and then mount, for example, you'd use fdisk L to list the various partitions. We know that devsda1 contains root, so we could mount devsda1 into temp, which we've just created. And now, when we take a look at our mount table, we'll see that temp contains a structure that's of interest. And then we could make changes in temp and then reboot the system. We could also change root /temp to make it the root file system. And then you'll see now that devsda1 is indeed the root file system in this area. So these are some different ways of doing it. Now let's exit the shell and we'll reboot. And now we're back. So that's it. A little bit about how to use recovery mode to bail you out of boot-related issues, which are normally the problems associated with Linux startup environments and their problems.